Hey, what's going on, guys? Let's do this problem right here. The question is asking a thin 30 centimeter times 30 centimeter flat plate is pulled 3 meter per second horizontally through a 3.6 millimeter thick oil layer sandwiched between two plates, right? And one stationary and the other one is moving at a constant velocity of 0.3 meter per second as shown in the picture. The dynamic viscosity of the oil is 0.027 pascals second, and the first question is asking plot the velocity profile and find the location where the oil velocity is 0. So what's going to happen is here. So this is, let's say this is the way oil is moving, right? So since this is moving this direction, what's going to happen is, and we are having a VW in this direction, that is the Volt's velocity. So that's going to affect this fluid velocity, and that's going to create a pattern like this, right? So the point is going to be 0 is if I take this one as A, this point is going to be 0 velocity. The difference, the change occurs. So this is 0 velocity, and this is the distance we have to calculate. For the first question, they are asking for the find the location where the oil velocity is 0. So let's see how we can calculate this one. So let's say this is YA distance, and if this is YA, what I can do, I can take a similar triangle to solve this problem. So if I take similar triangle, this is going to be, so we are going to have 2.6 minus YA, that is this one right here, 2.6 minus YA divided by this one, that's going to be YA, that is equal to, so we can equalize this one with the velocity right here, because for this one velocity is, we can consider this distance as velocity. For this one consider as velocity, right? So this is, so we are dividing the big one by small one. So big one, the velocity is 3, and for the small part is velocity 0.3. So 3 divided by 0.3. Then from this equation we can calculate the YA. That comes out to be 0.23636 millimeter, and that is the location this velocity is going to be 0 in the fluid, right? And that is the first question. Let's do the B part. They are asking determine the force that needs to be applied on the plate to maintain this motion. So to find this, I had to take the shear force in the upper direction and the shear force in the lower direction, and then combine them together, and that's going to be the force that's going to be required. So let's take upper direction, F shear upper. So if I take upper direction, we are going to have shear stress times upper area, that is this area right here, 30 centimeter flat plate, right? So that is the area we are going to apply right here. So this can be written as mu, that is viscosity, as area du by dy. So du is the velocity difference. In this case, what is the velocity difference? Let's see. Mu as, in the top it's fixed volt, so it doesn't move, only this one is moving right here. So this is going to be 3 minus 0. So 3 minus 0, so we can say v minus 0 first, v minus 0 over h1, and if we substitute all the values, we have the viscosity provided right here, that is 0.027 pascal second, or you can say Newton per meter square seconds for the same thing. So this is going to be 0.027 Newton second per meter square, because Pascal is equal to Newton per meter square, so I can write this one as that one as this one too. So this is mu times the area that is provided in centimeters, so we have to convert this into meter, that's going to be 0.3. So here we are going to multiply this one by 0.3 times 0.3 meters square, and then we have this du, the velocity difference, that is v minus 0. We already did that. Here the v is 3, right? 3 minus 0. So this is also multiplication, 3 minus 0. Then in the bottom we have the distance right here, that's 1 millimeter. So if I convert into meter, that's going to be 1 times 10 to the power of minus 3. So we are going to divide this 3 by 1 times 10 to the power of minus 3, and that's going to be the total shear force in the upper part. So if I calculate this one comes out to be 7.29 Newton. And then we are going for the lower part. So let's take the lower part. F shear lower. So it's going to be same thing. Shear stress multiplied by the area. Shear stress lower multiplied by area. Shear stress can be written as mu A. It's area times du by dy, right? Du by dy. Then we plug all the values like mu as. Here we are having the Volt's velocity, so that's going to be deducted from this. V minus Vw divided by h, that 2 right here. And let's put all the values. So viscosity is going to be same thing. That's going to be 0.027 newtons second meter square times area, also same thing, 0.3 times 0.3 meter square. Here the velocity is changing, that is 3 minus, because we have the Volt's velocity, that's 0.3, so we have to deduct that one from this one. And in the bottom we are going to have the height right here, that's 2.6 times 10 to the power of minus 3. So 10 to the power of minus 3, and if we multiply everything we get 3.08 Newton. So the total force required for this one to required to maintain this force is going to be addition of these two. So that is going to be, let's write it in a different color. So we have that F is going to be equal to F upper, F shear upper plus F shear lower, that is equal to 7.29 Newton plus 3.08 Newton, that is equal to 10.4 Newton. And that's how it's done. I hope you guys like this video. See you next time.